I am going to try to make this series of videos to show you how to use the Haasoscope Pro. First up, how do we download the code, install the necessary driver, and get the software up and running. So I'm here on the Haasoscope Pro GitHub page. The link is right here, and you've got all the code for the Haasoscope Pro here, and down in the README you've got some nice pictures, some schematics, routing overview, firmware overview. We can take a look at those later maybe, but for now let's just get up and running. So I've got this quick start here. It runs on Windows, Mac, or Linux. I'm running on Windows here, so that's what I'll demo right now, but I'll talk about how you can do it on Mac or Linux also. Quite easy. So the main idea is, first of course you need the code. So how are we going to get that? Well, this is a Git repository, so if you're familiar with Git, then it's easy. You just clone this repository. So you've got the instructions here if you want to do it that way. No problem. That'll get you all the code. If you're not a Git person, then you can just download a zip file which contains an archive of all the code in this Git repository. So you can click on that, and you'll end up with a directory. Let's see, I'll go ahead and do it. Why not? So if I go over to my downloads folder now. Okay, so here's my download folder, and it's downloaded the file, and I can just extract all. Great. That might take a second. Okay, this is finishing up now. Took about a minute, and now I've got my Haasoscope Pro main folder here. I think inside of there's another Haasoscope Pro main, and I like to just rename this Haasoscope Pro, and then we can put that back in the download folder, and just get rid of this other stuff. And great, now we've got a Haasoscope Pro folder, and it's got all of our code in here. All right, the first thing we want to do is now look at installing the driver. Let me go back to the GitHub README here. So we're in this quick start section, and we did this. We downloaded the code and unzipped it. We renamed the Haasoscope Pro to Haasoscope main to Haasoscope Pro. Why? Because Git will name it just Haasoscope Pro, and you want the instructions and stuff to be consistent. So I don't know. I like it, but it would work if you just left it or whatever. But the next step here is important. You got to install this FTDI driver. That's what you're going to be using for talking over USB to the Haasoscope Pro. So it'll work on Windows, Mac, or Linux. On Windows here, what we're going to do is I've already included the setup executable in the software directory. So we go to Haasoscope Pro software, and we should see that executable there. So we go in the software directory, and there it is. So I can run it. I mean, I already have the driver installed, truth be told, but we can run it again. So it's just going to do that, your usual driver install nonsense, and there, you're done. So there we have the driver. If you were on Mac or Linux, there's a shared library. So for Mac, it's this file. It's also in the software directory, And for Linux, it is this shared object file, also in the software directory. All you have to do is this command, sudo will give you like administrator privileges. So you'd open up a terminal window and just type in this command. It's going to ask you for your password because it's got a copy to a system directory, and it's going to copy this shared library to this directory in your system. Same thing on Linux, except it puts it in user lib instead of user local lib. And that's about it. Then you have the driver install. Okay, next step is exciting one. Plug Haasoscope Pro into your computer via USB. So I've got a webcam here set up showing the Haasoscope Pro. I've also got this handy current and voltage meter, which you can use to see what's going on there. So right now it's just at your USB 5 volts, and it's not really drawing any current because nothing is plugged in. So how do we plug it in? Let's turn this around so we can see the back. And what do we have on the back? Well, right in the middle we have our USB-C 2.0, and this is for data and power. So it takes about 5 volts, 2 amps, like it says on the back of the box here. We can test that out. So we'll plug this in. And yeah, at the moment we're drawing about 0.8 amps, so not so much, but that's because it's not really on yet. We haven't started the software, so the ADC is basically like in a sleep mode, and so not too much is happening. We'll go back to the front so you can see what's going on. I'll just mention there is this optional 12 volt 1 amp power input. If we do that, so this is not included, but if you happen to have one at home, you could do it this way. You plug that in. Now you see we're drawing no power basically from the USB at all. In fact, it's totally disconnected from the USB power, and we're drawing everything from that 12 volt connection. So that's handy if your computer isn't able to supply enough current through USB at 5 volts. Most can, but if yours can't, then that's one way to get the Haasoscope Pro working for you. Another way you can do it is using a powered USB hub, a powered, like a little dongle. Let me see if I have one. No, I couldn't find one, but yeah, they look like this. You plug this into your computer, and then this is the power adapter part here, and that's that could come from the wall, like a USB charger, USB-C charger, and then these USB ports are then powered, and we'll have plenty of current to power the Haasoscope Pro. Okay, so we'll unplug this for now, and we'll turn this back around so you can see what's going on the front. You can see we've got our 2 LEDs, and they're just white right now, which just means like, hello, I'm on, but I'm not really like doing anything. But it's ready to go. So the next step is run Haasoscope Pro Qt in the directory for your given operating system. So let's take a look at that. So we have to go in this dist directory, and you've got Windows, Mac, and Linux. We're on Windows, so we'll do that one. And we've got Haasoscope Pro Qt. So that's it. We just run that. Double click. Okay, whatever. and it's going to pop up a terminal here. Yeah, sure, allow access. It is actually opening up a TCP port, and yeah, you can see it here, socket listening on localhost 32.0.0.1, and that's for connecting from Haasoscope client, which is another GUI we'll talk about later, but yeah, that's what that's for. So let's move this down here so we can see everything. And yeah, here's our GUI. So yeah, you can see a few things. This is actually turned red. Can you see that it's red? It doesn't look red on the camera, but it looks red in real life because it's so bright. The camera is just saturated. So the idea here is that the color of the LED is going to match the color of the trace on the screen. So the first trace is red, and so we've got a red one there, and then that light next to this input means that it's this input which is going to affect this trace, right? And the other input is off, so the LED there is off. You can also see we're now using close to 2 amps. And if you listen closely, the fan has actually started up inside the unit. It's pretty quiet. You can barely hear it, but if you put your ear next to it, you can hear that it's started up, and that keeps it cool. The temperatures are actually being monitored of the board and of the ADC itself. Might do something with those later, but for the moment they're just being monitored, and you can see them rising slowly, but nothing too extreme. Okay, what's next? So we can kind of look at what all this junk is. You know, this is looking for USB devices. It's doing some stuff to see if there's any other Haasoscopes connected, because as we'll talk about later, you can connect multiple of them to your computer and sync them up for multiple channels and oversampling. So we'll talk about all that later. But we just have one connected, so it's saying board 0 is the first board. What else? Then this stuff is all just, you know, setting up the clocks and setting up the ADC and all sorts of technical stuff, but you can take a look if you want. Finding the right phases to run the clocks at, and you should be good to go. I will mention this phase thing, so there may be times when you see like weird glitchy things going on a trace, like little spikes and stuff, and something clearly seems wrong, like where did this noise come from? It may be that you need to reset the PLL. When you do that, clicking that button there, see it's going to do a scan, and it's going to find just the right phase to run your PLL at, which is basically the clock telling the ADC when to collect samples, as compared to the FPGA clock, which is reading out the ADC. So those two kind of have to be in sync, and if they're a little out of sync, then you'll get some corrupted data into the FPGA, basically. So it does a scan, and it finds kind of the best place to put that phase, and it's a pretty wide window, but yeah, if for some reason it gets put out of whack, then you just click that button, and it'll all be hunky-dory again. I might work on some way to kind of automate detection of those errors, and so you don't have to deal with that, but you know, that might be coming later. Resetting the clock itself isn't really going to do anything. That usually just runs fine, but that's what that button does. Okay, so yeah, now we have it up and running.